Hello, everyone. I am Cristian Henríquez from Católica University of Chile. I will present ARClim project. Um, the ARClim project is the Spanish acronym of Climate Risk Atlas of Chile. And this is an interesting project because it involves the public sector and academia. This project was developed in 2019 and 2020. Um, this project was elaborated by Ministry of Environment and financed by Federal Ministry for Economic Cooperation of Germany. This project was developed by Climate and Resilient Research Center, CR2, from University of Chile, and Global Change Center from Catholic University, that I work in this university. And with the collaboration of several national and international institutions. In fact, the project involved more than 19 experts, 15 working groups, 31 Chilean research centers like university, 25 EPC models run at resolution 5 kilometers, 45 indicators, and 12 sector were analyzed. One sector is the city sector, 55 impacts, and more than 300 maps was elaborated. And finally, three website was elaborated for the website. The objective of this work, in first place, is develop a set of climate risk map related to the city sector using a common conceptual framework and a consistent database. This was a national level. Second, to communicate climate hazard, exposure, vulnerability, and risk at national level for the 34 major cities in the country. Finally, to deploy information on a web platform, becoming a useful tool for policies, public policies, and implementation of adaptation measures. The conceptual framework is taken from EPC Assessment Report 5 and specifically taken from GIS and EURAC report. This include the concept of impact chain that include the hazard, the hazard, the exposure, and vulnerability. And the vulnerability has two elements: the sensitivity and capacity. We work in ARClim with sensitivity concept. This is the site of ARClim. It's in Spanish, of course. This is the 12th sector. The sector health and human welfare include the subsector city. And we developed three impact chains: urban health island, thermal discomfort, and frost. And in the case of the general methodology, we use a hazard indicator for the present and the future using the temperature. For the exposure, we use the census data for calculate the total inhabitant in the 34 city for the present and the future. And sensitivity was developed using the Social Vulnerability Index, SOVI, proposed by Susan Carter. And finally, the risk impact was applied to urban health island, thermal comfort, and frost. We applied this very simple formula to integrate the three elements of the equation. Here's the impact chain as example, or urban health island. We can see the hazard indicator. This is constructed by the formula proposed by Professor Oke that included the population and the wind speed. Why? Because we need to model the present urban intensity heat island that affect thermal stress and future urban heat island. And this parameter of population was derived from land use modeling to 2065. Then we can extrapolate the population, the future population of the city. The exposure was calculated by the census data and the model of land use change that show in this image. Vulnerability was constructed by social vulnerability index. This is an indicator composed by 22 socioeconomic and demographic variables, plus number of slums in each city. Well, this is the methodology specifically for the urban health island, and here's the result: the map of hazard, exposure, and vulnerability. The colors represent different levels of the hazard, the exposure, the same thing, and vulnerability. The vulnerability has the only indicator that not can be projected in the future. Hazard and exposure we can extrapolate to the future. And here we the present risk and the future risk of the urban health islands for the 34 city. In this case, Santiago has the most intense urban health islands, near to 10 Celsius degree. In the future, Melipilla, Rancagua, Machalí will have the high risk together with Santiago. The estimation was validated with a data logger located in different part of the city. This is a rural side, this is the center of the city, and the result is very similar to the estimate from OK formula. Well, the second stage of ARClim project include the adaptation because it's not part of the formula. This formula only considers exposure, vulnerability, and risk. What happened with the adaptation? In this case, we propose three kind of indicators of adaptation: implementation indicators associated to planet adaptation, progress indicators associated to the exposure and vulnerability, and output indicators. In this example, thermal comfort, for example, the land use plan might be considered a implementation indicator. But this plan is executed. This is progress indicator. For example, area of green infrastructure, square park, and wetlands. And outcome indicator might be the rate of annual hospital admission due to heart stroke. Other example we developed is the impact chain of fire in urban settlement. In this case, we have the three elements of ARClim, original ARClim's proposed. Of course, the data has been normalized, and we add the adaptive capacity. In this case, we show the communal rate of number of fire company for per 100,000 inhabitants. This formula include the adaptive capacity and K factor. K factor is a parameter that reduces the vulnerability to a level near to zero. This K factor was proposed by workshop with stakeholders, several stakeholders. Well, in conclusion, the risk mapped in 34 cities show that non-urban area will be exempt from impact of climate change, although the impact on frost will be the less significant. Here don't show the frost result, but it's interesting the frost because the most part of the city the impact decrease. Of course, in winter it's more warmer. This can be considered a positive impact. Second, through participatory workshop, new indicators of adaptive capacity are proposed. Implementation, program, and outcome indicators for each impact chain. This is the most important of the governance. Third, important of monitor and evaluation is K2 climate risk assessment. And finally, the framework of law of climate change. The last year, Chile has this law on climate change, state to adapt to climate change, reduce the vulnerability, and increase resilience to adverse effects of climate change. This is an example of the law of climate change, in which we can see the Article 51 propose the platform of adaptation, climate adaptation. That means is the ARClim, basically is the ARClim project. And the ARClim project also we use in guide to environmental impact assessment. The policy maker must be considering result of ARClim to make this evaluation. Thank for your attention. For more information, here's the website of ARClim.
Thank you very much, Christian. Are there any questions? Ronaldo.
Thank you very much for the presentation. Very interesting. I noticed that you mentioned the number of slums in your assessment. Did you also consider the size of the slum of the population inside them?
Yes. In this case, we consider only the quantity of slum per city because this is interesting question because after the pandemic, the slum are multiplied in several cities of the country. It's a very huge problem. And this indicator is not proposed original by Susan Cutter, the Soviet indicator. We add this indicator because Chile is a developing country and this is a very critical topic.
Good. Thanks, Joe. Professor, very good talk. Thank you for telling us about the situation in Chile. A question about how you look into risk assessment and adaptation 2065. How do you go about quantifying the social vulnerability or how slums might change in the future or how demographic change might happen? So I think I'm interested to know the challenges of how to overcome those problems for predicting future risk. Thank you.
Thank you for your question. Have you mentioned the vulnerability have not projected for the future because it's very difficult to know how much evolve the condition of the people, urban people, and the pandemic demonstrate that is very uncertainty because 1 year the situation changed everything. The level of poverty is elevated, but it's very difficult. But the exposure and the hazard is possible project in the future because in hazard we use model in high resolution model and exposure we project with the land use change modeling developed with third set program.
Thank you very much, Christian. Our final speaker today is